I'd like to talk about this problem which we did on Friday the 9th. This is a problem about position, velocity, and acceleration, and it's a pretty important type of problem that you're going to see on the AP test. It's a problem where you're given a velocity and it has been plotted here versus time. So you have velocity in feet per second and time in seconds. And we're asking various questions about the motion of this particle or this object. So the first question is, when is the object moving at a constant speed? So that is when the velocity is not changing from t equals 0 to t equals 1 second. When is the particle moving to the right? That will be when the velocity is positive. In other words, from t equals 0 to t equals 2 seconds. When is it moving to the left? That will be when the velocity is negative, and that happens from t equals 2 seconds to t equals 5 seconds. When is the particle speeding up? Speeding up will happen when either both the velocity and the acceleration are positive or both the velocity and the acceleration are negative. In this graph, this is a graph of velocity, so the slope of the lines in this graph is the acceleration. Okay, so when we are looking at the graph and trying to see when the object is speeding up, we're looking for positive velocity and positive acceleration, which never happens, because here we have positive velocity, 0 acceleration. Here we have positive velocity, negative acceleration. Here we have now negative velocity, negative acceleration. And over here, negative velocity, positive acceleration. So the only time when the particle is speeding up will be from t equals 2 to t equals 3 seconds. Particle will be slowing down when the velocity and the acceleration are opposite signs. So that is going to happen in two places. One is t equals 1 second to 2 seconds, and the other stretch of time will be 3 seconds to 5 seconds. In those two zones, in other words, here and here, velocity and acceleration have opposite signs, and that means that the object is slowing down. When is the velocity increasing? Velocity is going to increase, just looking at the graph, on the stretch of time from 3 to 5 seconds. When is velocity decreasing? That is going to be from 1 to 3 seconds. Now, number 8 says, are your answers to 6 and 7 the same as to 4 and 5? And this is the heart of this lesson, is the answers are not the same because speed is not equal to velocity. Speed is equal to the absolute value of velocity, which is why our particle in the time t equals 3 to t equals 5, the velocity is actually increasing, but the particle is slowing down. Velocity is becoming less negative, so it's increasing, but the particle is slowing down because the magnitude of the velocity, or the absolute value of the velocity, which is speed, is decreasing. Moving on to number 9, we're asked about the speed of the particle at t equals 4 seconds, and that is going to be 5 feet per second. Speed is always either positive or 0, never negative. The velocity, on the other hand, at time t equals 4 is negative 5 feet per second. The average velocity, I'm going to skip this for now and move on here to number 12. When does the particle change direction? Well, it's going to change direction right here at t equals 2 seconds when velocity goes from positive to negative. How far does the object move during the first second and which way? Well, it moves 5 feet per second is the velocity times 1 second, so it's going to move 5 feet in that first second. Notice also that that 5 feet is the area of this rectangle right here. Now in question number 14, we're asked how far to the right does the object go and when does it arrive there? We are now looking at the total distance traveled to the right, which means it's going to be for this length of time when the velocity is positive, how far have we traveled. So we figured out that in the first second we traveled 5 feet. In the second, the distance traveled is going to be the area under this triangle. So the area under the velocity curve is going to be the distance traveled. That's something that we're going to prove in the next chapter when we study integration. But for now, we just take it on faith that the area under this velocity curve is going to be the distance traveled. So the area of that blue triangle is going to be 1/2 of the base times the height. And so that comes out to be 2.5 feet. And so in the time t equals 1 to 2, the particle travels 2.5 feet, and the total distance traveled now to the right is going to be 7.5 feet. Okay, so the next question 15 asks for the total distance traveled overall, the total distance in the 5 seconds, and that's going to be a similar calculation where we have to calculate the area under this yellow triangle and also the area under this green triangle here. So if you do that, you can add up all of those areas and you end up with 22.5 feet as the total distance that has been traveled by the particle. The position of the particle, though, is different. It's not going to be 22.5 feet. It's going to be, you can consider it to be like this. 5 feet was traveled in the first second, 2.5 feet in the second. Then the particle at t equals 3 reversed, at t equals 2, reversed direction and went back 5 feet. And then it continued in a negative direction, and at t equals 5 seconds now, it's traveled another 10 feet. Okay, that may be clearer if I labeled these areas. This yellow triangle had an area of 5, and this green triangle had an area of 10. So that's why I'm going back 5 feet and then 10 feet in the negative direction. Okay, so I am ending up at a position of negative 7.5. If I started at 0, I've now ended up at a position of negative 7.5, and that's my answer here for number 16. Okay, number 17 now asks, what is the average velocity over the 5-second time interval? Well, that is just going to be the change in position, so delta S over delta T, which is going to be the final position minus the initial position over the change in time, so which is 5 seconds, so that will be minus 1.5 feet per second is the average velocity. Number 18 asks about whether the answers to questions 15 and 16 were the same, and they're not. And the reason is because 15 calculated the distance traveled and 16 calculated the position, the final position. Those are two different things. The total distance traveled does not take into account the direction of motion, so we just add up all the distances, while this position does take into account the sign of the direction that we're traveling in, and so distance and position are two different things. What is the average speed over the 5-second interval? Well, the average speed is going to be the total distance traveled divided by the time. Notice that for speed, we use the total distance traveled. For velocity, we use the position. So 22.5 divided by 5 gives us 4.5 feet per second for the average speed. What is the particle's acceleration over the first second? So the acceleration is 0, and that is because the velocity is constant over the first second. Over what time interval, number 21, does the particle have a positive acceleration? Well, this is when the slope is positive, and that happens for t equals 3 to 5 seconds. When does it have negative acceleration? Well, that's the slope negative, and that happens from 1 to 3 seconds. Acceleration is undefined. Number 23, acceleration is undefined at t equals 1, at t equals 2, and t equals 3. Notice that that is the same thing as saying that the function, the velocity function, is not differentiable. Velocity function is not differentiable at those points because there are sharp corners at all of those 3 points. In number 24, we're asked about when does the object have positive acceleration but is slowing down. So that would be, we are talking about, for slowing down, the velocity has to be of a different sign than the acceleration. So if the acceleration is positive, then the velocity has to be negative, and this happens for the stretch of time t is 3 to 5. State an interval when the acceleration is negative and the particle is speeding up. So we know for speeding up, both of the quantities have to have the same sign. So that means velocity has to be negative and acceleration has to be negative. That happens when t is greater than 2 and less than 3 seconds. Next is, what is the acceleration over the time t 3 to 4 seconds. So we are looking at the graph and just looking at the slope in that time between 3 and 4 seconds, which is right here. And the slope is just 5 feet per second squared. 5 feet per second, so 5 feet per second squared. 27, average acceleration over the entire 5-second time interval. V average is going to be your final velocity minus your initial velocity over the change in time. Final velocity is 0, initial velocity 5, change in time is 1. So V average is going to be minus 5 feet per second. Last question here asks, over what time interval is the velocity decreasing at a rate of 5 feet per second every second? So we're looking for a time when velocity is decreasing. That is going to be from t equals 1 to t equals 3. And within that period, the slope is 5 feet per second squared in the time interval from 1 to 2. Just looking at the graph and at the slope, we can figure that out. So we can summarize most of what we've said in this table at the bottom, where we are looking at different possibilities of combinations of velocity and acceleration. So if velocity is positive and acceleration is positive, we are speeding up. If velocity is negative and acceleration is negative, we are also speeding up. If velocity is positive and acceleration is negative, then we are slowing down. If velocity is negative and acceleration is positive, in other words, opposite signs, we are slowing down. If velocity is 0 and acceleration is greater than 0, we are starting from a stop. If velocity is 0 and acceleration is less than 0, we are going backwards from a stop. So we can say starting back from stop. If velocity is greater than 0 and acceleration equals 0, we are moving at a constant velocity. Same thing here, constant velocity backward. This one is constant velocity forward. This one is constant velocity backward. And lastly, velocity equals 0 and acceleration equals 0. We are at a stop, complete stop. And that's the end of that problem. I hope that it was helpful.